All right, hello class. This is just a supplemental video to help you visualize this recursive function that we just wrote in class today to clear a linked list. All right. Now I kind of just threw it at you, right? And I kind of made some changes around, and a lot of you maybe had some confusion. So let's visualize what this looks like. Now I'm going to point out a few things to begin with. Number one, notice that we have a pointer passed by reference, okay? This is a bit of a tricky thing to think about, but this pointer is passed by reference, meaning we're going to pass the actual location of where that pointer is stored. All right? And you'll see how this looks. So let's pretend like we have a pretty linked list like this one. Now it's kind of oriented top down to help you visualize this. Now the first thing we're going to do is we're actually going to assign memory addresses to each of these. Now I apologize for the small text, but we're just going to kind of wing it here. So we've got 0x0a there. Let's pretend that we've got 0x0f, and then this one might be 0x04 or something like that. Okay? 0xa, 0xx, and 0f4, or 0x4. Now, thing to remember is that these are linked list nodes, meaning that these arrows are pointers to the next node. So notice here that this one is pointing to null pointer. So the best way you can think about this is up in here you're going to have some next pointer which is equal to null pointer, right? In this one, what does the next node equal to? Well, that one is equal to 0x4, right? Let's point that out real quick. Next equals 0x4. That's because it's looking here at 0x4, right? And finally, we're going to have, say, the next node up here, which looks at 0xf. All right? And once again, just to point that out to you, next node is looking here. This is where this pointer lives. It lives inside of this node, and it's pointing to this memory address. It lives inside of this node, and it points to this memory address. So this is our linked list. All right. Of course, there's some elements in here too. If you want to think about those, this might have, I don't know, a 3 in it. This might have a 4, and this might have, I don't know, 66, 55, something like that. So let's begin. So say we call clear list on the head, right? Which is a node pointer by reference. It's by reference. So similar to class, let's say we have a function call here. And there's some things to keep in mind here. Well, the first thing is, let's make this just a little bit bigger. We're going to pass in some value. Well, let's think about it. We're passing in the head node. What is the head node pointing to? Well, it's pointing to 0x0 or 0xa, right? So that's what n is. That's what n is. N equals 0x0a. So the first thing we check is this. Does n equal to null pointer? No, it actually equals to 0x0a. So what happens? We call clear list. This is the recursive component right here. We call clear list. Now, this is a void function. This is a void function. Now, in a void function, there's always an assumed spot to return. All right? There's an assumed spot to return. And that's here. In fact, in your code, you never need to have this here. It's assumed. At the end of a void function, there's always a return at the bottom. So what you need to think about here is that this is not returning. This is not a return statement. This is actually just a straight up recursive function call. Similar to generate permutations, right? Similar to that. This is just a straight up void function call. So it's not returning anything. So what does that mean? Well, it means that we call ourselves again, right? So you grab, your function bubble, pass it down here. Remember that you're calling yourself, so I do want to have some nice arrows here to indicate that we called it here. And then what happens? Well, what did we pass? What did we pass to this function? Well, we passed n next. So if we're looking at 0xa, what's the next of that? Oh, it's 0xf. So we pass in 0xf. Okay? Now we're back in our recursion, right? So is 0xf equal to null pointer? No, it's not. Clear list on the next node. All right, 0xf, what's next? 0x4. What do? We recurse. Come down here. Let's bring a nice arrow with us. There you go. And what did we pass? Well, we passed this value of 0x4. There you go. Now we're back in this clear list function again, right? Can't believe it. Here we go. Is n equal to null pointer? No, it's not. It's equal to 0x4. What do? We recurse. 0x4, what's the next? It's null pointer. It's null pointer. So now we might be getting somewhere. So what do? Well, we grab our recursive function. It might not need that, so I'm just going to bring this here instead. Remember that it calls itself, right? So I'm going to bring in an arrow here. I'm going to kind of overwrite this. Wow, that's amazing. Okay. And then what does it get? Well, it gets this null pointer value, right? It gets this. Oops. So we'll pull that in there. There you go. So finally, we're at the bottom, right? Because what do we say? Does n equal null pointer at this point, right? We just call ourselves again. So now, does n equal null pointer? Yes. And look what happens here. It's a return. What happens on the return? No more recursion, right? So nothing happens in this function. In fact, all of this stuff gets skipped. And it's good, because if it didn't get skipped, we'd segfault, right? Because if n is equal to null pointer, we get a dereference here, that's a segfault. We get a delete here, that's an invalid free, right? So it's good that we're returning. So what happens on the return? Well, we're finally done, which means we come back up here to this function, and we actually resume execution of the previous function. Why is that? Well, notice it was called here. So now that this is finally returned, we will continue on. Hi, Patty. So we're going to delete n. All right, we're going to delete n. So what does that do? That says, hey, goodbye. I don't need you anymore. And then what's the next thing that happens? Well, we've got n equals null pointer. Now, this is the important part. Remember, pass by reference. This is pass by reference. N equals null pointer, pass by reference. So where does this n live? Well, guess what? It lives right here. That's where it lives. It lives in the previous node. So guess what, folks? This becomes null pointer. Kind of hard to see there, but I've overwritten it. That became null pointer. All right. And then what happens next? Well, we subtract the size, and what do you know? Return statement again, right? Return statement again. So what does that mean? It means we come back up here. There you go. And then we continue execution of the previous function call. Execution of the previous function call. So we surpass that. Now we're deleting n. What does that look like? Well, we grab our arrow, our x, and we say goodbye. Right? And then we say, hey, what's next here? Well, we're going to assign n to be null pointer. Where does that n live? Well, it lives up here, so that becomes null pointer. Size -1, return. Now, we resume execution of the very first function call. What's the first thing that happens? We delete n. Goodbye. Then what happens next? N equals null pointer. Well, what is this one? Well, guess what, guys? It is the head. The head node gets updated to be null pointer. So the head node gets updated to be null pointer, size -1, and we return, and we're done. So we've officially deallocated our list. My favorite word was from Top Wolf on this one. We deallocated it in a special way. We deallocated it inside out. We deallocated it inside out. And that's why this function works. Now remember, just to reiterate, this is not a return statement. If you want to look at some of the code that's different here, let's go ahead and take a look at some of the other programs. In program 2, notice here that we're calling it as a void function, meaning that this for loop will continue to execute, right? So after this returns, the for loop continues to execute, and then it finally hits probably an imaginary return down here, unless you specify it, of course. But this is where people get caught up here, on this one, the calculate square miles. And I saw many of you doing this. Many of you did this. Many of you put a return statement here, return that. Oops, go away. You put a return there. And then you did this, something like that, right? One of these was a -1, the other one was a +1, and the other one was a -1. Now what's wrong here? Well, as soon as you hit a return statement, similar to this kind of image here, we go back up, right? Obviously, when you're hitting the return statements, you go back up. Except the thing that you have to consider here is that this bit is a recursive call to itself. Recall that the return type of this is an unsigned integer, and that's why we're allowed to return it. So this function cannot return until this is evaluated. Once it's evaluated, then it can return. And the other thing to keep in mind here is that there is a return statement here. So once this finishes, nothing after it executes. Nothing after it executes. That's probably why I wanted you to do something like int total equals that. And then here, down here, you'd say something like total plus equals that. Right? Because these returns are going to prevent you from continuing to recurse. So I hope that was helpful. Best of luck with assignment 1 and stuff. I'll be uploading a video on that soon. And I'll catch you guys next time.